today.
Oh my gosh, I forgot my shoes. You talk to him.
He forgot his shoes. This is ridiculous. Listen, right now he is running into his shoe room, because that's a thing, and grabbing shoes, not to put them on, mind you, but just to show you another pair of shoes. That's what's happening right now. While we're waiting on him to get his shoes, I'll tell you that we're about to talk about 1.9. There are only 10 sections, so we're getting close. Do we have shoes now?
We do have shoes. How dare I forget my purple shoes?
Wow, they even have like gold toes and gold, what's that thing called?
That's a tassel.
A tassel, yeah, a gold tassel.
And yeah, it's beautiful. And they're
Are those velvet?
they're velvet.
Those are ridiculous.
I really miss being able to, like,
Wear shoes.
wear shoes. I haven't worn shoes in like 3 months.
Okay, so guys, the great thing about today is there's really no new content in this lesson. We're gonna try to take all the stuff that we've talked about and kind of put it together to answer some questions. So grab a piece of paper, answer the questions as we go through, and let's see what you've learned. Would you say?
Yeah, they might want to actually listen to us, but whatever. Go.
You don't have to. Yeah, you might want to listen. Okay. So essential knowledge on this case is actually just taking any graphical representation or number summary and of two different variables, and just to be able to compare them. So that's kind of what we're focused on here. Remember that when we compare distributions, we're still using CUS and DS, center, unusual, shape, spread, and be specific to the prompt. Now, as I'm telling you to be specific to the prompt, I will tell you that this first comparison it's nothing.
Yeah, there's no. She gave up. She quit.
I did. I'll tell you what I told Mr. Bobby, because I feel like you should know this too. I don't often just pull graphs that don't pertain to anything and aren't interesting at all. But you guys haven't seen a uniform graph yet. So I wanted you to see that, and I'm giving a little bit away here, but that's kind of why I had to do this. So now's a good time. Pause, CUS and DS? That's not right. CUS and DS, and then we'll do a 3, 2, 1 countdown, and we'll talk about it.
Oh, yeah, 3. All right, let's talk.
Okay, so I hope you started with center. And so when we're talking about the center of these two graphs, we're talking about the medians, maybe. And so both of the medians, as you count in, look like they're between 4 and 5, and they're about the same. Make sure you say they're about the same. You don't just say both of them, or you don't say something like variable A looks like it's about 4 to 5, and variable B looks like it's about 4 to 5. Because you haven't compared at that point, so you have to actually say something about the both of them.
Linking the two, yes.
Right. Then you talk about anything unusual. These are boring graphs. Not only do they not have any specific variables, but there's no outliers, no gaps, no clusters, nothing interesting about them. And then the shapes, they're quite different. Variable A appears to be uniform or approximately uniform, and the second looks like it's approximately symmetric.
You might even say the first one's like a rainbow.
How is it like a rainbow? No, you're a rainbow. The first one is a uniform. Then we want to talk about variability. Now, there is a little bit of like interesting thing you could say about variability here. Right?
We could find the range, but again, that would be kind of boring because the range of these two graphs would be approximately the same. But what about the standard deviation? Well, what was the standard deviation? Was the average that a point is from the mean. Well, since B is clustered, or not clustered, is peaked near the mean, more points are closer to the mean in variable B's graph. So I would say that variable B has a smaller standard deviation compared to variable A.
Right. So if you're trying to explain these graphs to somebody and you just talk about the range, you're not really giving them any information about how the data is distributed. Okay, let's go off that boring one. So here's the next one. It says a study in Switzerland examined the number of C-sections performed a year by samples of male and female doctors. And we've given you the summary statistics in this case, and we're going to ask you some questions. So you have here the difference, standard deviation of the sample, min quartile 1, median quartile 3, and then the maximum. So go ahead and pause and try to answer A, B, and C, and we'll give you a 1, 2, 3 or 3, 2, 1 countdown, and then we'll talk about it.
I can do it right this time. 3. Quit laughing at me. All right, it's good to go.
Okay, so based on the computer output, which distribution would you guess has a more symmetrical shape? So, Mr. Bobby, when we're looking and trying to decide if something has a symmetrical shape, and we're thinking about a box and whisker plot, and why am I saying we're thinking about a box and whisker plot here?
Well, because you've got mins and Q1s and medians and Q3s and maxes.
Exactly. So if we're talking about a box and whisker plot, how do we know when a box and whisker plot is symmetric?
Well, we would have the whiskers being approximately the same length, depending on the thinking.
Right. And so we also could talk about the box itself and it being about each of those boxes inside the big box, see right there, would be about the same as well. So he's showing you right now, if we look at the length.
That distance is 7. I'm sorry, I thought you wanted to talk whiskers, but.
Yeah, let's talk whiskers.
That distance is 7, right? What about this distance of this whisker is 5. Is there a huge difference between 5 and 7? I wouldn't.
We need to be comparing just males and then just females. So you just compared a male and a female whisker.
Okay. Oh, so I want to go this one.
Right.
I'm sorry, my bad. Yeah, that would be 36. My bad. Yeah,
so we have one male whisker that is 7 and one male whisker that is 36. Is that about the same?
Not even remotely close.
Not even remotely close. Okay, now let's do the female whiskers.
I used pink for male, so I'll use blue for female.
Blue for female, I like that.
Because, you know, I got to be me. This one we already said was 5, and this one was, whoa, go with that. Okay. That one was 4.
Right. So are those about the same?
Those are closer.
Yeah. So if we're trying to decide which of these has a more symmetrical shape, we're going to pick the one that has the whiskers that are about the same. Now we could do the same thing and look at the box itself, although we could really base it off of those whiskers if we wanted.
That one's 23, and this one, let me do purple since that's what we're wearing today. That one's 18. And 18 and 23 aren't as far apart as 7 and 36. They're close enough. Okay?
All right, so we got females. We agreed on that. All right, B says, explain the IQRs of these two distributions, or explain how they can be so similar, even though the standard deviations are quite different. So what's the IQR, Mr. Bobby, of the males?
That was what I had right here, and that was 23, right? We had it a minute ago.
Yeah.
This one.
And so that's what he just did was Q3 minus Q1.
And then I'm going to do 29 minus 10, which is 19 for the females.
How about 9?
No. 29 minus 10 is 19.
You're right. You're right.
Yeah.
Woo! Y'all, we've been making y'all videos for like, I don't know, 10 hours now. We have changed shirts every time though.
Because the last 4 videos are all done on the same day, but different.
We 100% are on our 4th shirts of the day.
And you're off the top of your head. Sit back from your computer a little bit. All I'm seeing is like, there you go. You're a little.
Sorry. I'm like, ugh.
We're falling apart. Let's make it. We can make it. We can do it.
Okay. So why is the IQR 23, the standard deviation 20, the IQR 19, the standard deviation 10, or maybe we could, say, why are these IQRs so similar, 23 and 19, and these standard deviations so different at 10?
Well, that's where the whiskers come into play, and that's where that one whisker for the male doctors was so much larger. That outlier, or that potential outlier, that 86 is really like yanking it apart, pulling that data apart.
Right. And remember what standard deviation is. It's how does the data deviate from the mean. So if the females don't have a lot of deviation in their whiskers, and the males have a lot of deviation in their whiskers, then that's really gonna make the standard deviation quite a lot larger. Okay, and then does it have an outlier? Do either one of them have an outlier? So how do we figure out outliers for this problem?
Well,
so
since we have, I'm sorry, I was to say we have the mean, or the 5-number summary, so we would have to use the rule for outliers for medians, right?
Yep. It's funny. I also did IQR tests, and my math looked something like this. We could have done 2 standard deviations though, right? Because we're also given standard deviation. So you could have also checked with the standard deviation. But the problem with checking with the standard deviation, I just told you could do something you can't do as I'm talking out loud through this. We don't have the mean, and the outlier test using standard deviation requires the mean because you have to do 2 standard deviations above and below the mean and not the median. So never mind. Don't test with standard deviation unless you have the mean.
You have the mean. You have 41.3, don't you?
Well, that's, did we, yikes.
Go back.
So there's something weird happening here. This is not, I don't think this is the mean.
Well, you had something extra that I erased there.
Yeah. Well, I stole this from a textbook. This is what the textbook had. Yeah. So it could be the mean, but if it's not, then if you don't feel confident, then use the other one.
But anyway, I do want to talk about this. We have this max that's bigger, or that is bigger. Now that guarantees we have an 86 because that number is in our summary. So we have an 86, and that's actually going to be an outlier. But that doesn't necessarily, we don't know, when we have the 5-number summary, we don't actually have all the data. So there could be, there's a bunch of numbers between 50 and 86. There could be more. There could be an 85 in there. There could be something else. We just don't know when all we have is 5-number summary. But we know we at least have one outlier.
Yeah.
All right, moving on.
Okay, next question. It says the Highway Loss Data Institute reported the following repair costs resulting from crash tests conducted in October of 2002. The given data are for a 5 mile per hour crash into a flat surface. I cannot.
For both cars, for both a sample of 10 moderately priced cars, mid-sized cars, and a sample of 14 inexpensive mid-sized cars.
Right. Thanks. Maybe should have stopped at the last one. Okay, so pause the video. We'll give you a 3, 2, 1 countdown before we start again.
Oh, well, before we do that, you probably are wondering how you should do all this. Remember we told you not to do standard deviation? You watch the video about the calculator, you can do the 1 variable statistics in your calculator, or you can take this data and copy it over to Staplet, and the link is in you probably already used it, or it's in your syllabus.
Yeah.
You can do either way. We do not care.
Yeah.
Now,
Okay.
2, 1.
I need a thumbs up right now. Okay, so we're just, the first two I'm going to click through because this should be straight from your calculator or from Stapplet. So go ahead and check those numbers. If you don't have them right, then you may have the next two wrong.
And if there's some, if you don't agree to a decimal or you have more decimals, then it's fine.
Yeah. Okay, then part C says, is there more variability in the repair cost for the moderate or the cheap? So what do you think?
So if we look at this, the moderately priced cars have a standard deviation that is larger than the inexpensive cars, and also with the IQR. So I'd have to go with those moderately priced cars.
Right. And then the last question says, compute the mean. So you should have the mean already in your one variable statistics or your Stapplet. So you're just going back and getting that number. And then it says, write a few sentences comparing repair cost. So here's what I want you to be careful of. So you can check this and it's pretty straightforward, but if you used IQR in your explanation in D, then you would get points deducted.
Mean goes with standard deviation. Median goes with IQR or range. You cannot, and usually it's IQR.
Yeah. So just don't mix those two things together, okay? So because it asks us to compute the mean, that automatically tells us to discuss standard deviation. Okay, box plots. So in a recent, you know what? You read, since I keep failing at it.
Consumer Reports rated tablets. Me and my tablet, look at me, like, see, hey, look, it's like math inception. They rated these tablets for performance and quality based on several variables. The magazine gave each tablet an overall rating, where higher scores indicated better ratings. The overall ratings for the Apple tablets are in the green graph, and the Samsungs are given in the graph below. Samsung's is the yellowish graph. And they're parallel box plots with their number summaries.
Yeah. So what you're doing here is you're comparing the distributions. So you're custom BSing the distributions. And go ahead and take a moment to do that. And Mr. Bobby will give you a 3, 2, 1 countdown before we begin again.
Okay, let's see if I can do this a different way. 3, 2, 1.
That could have gone bad real fast.
Yeah, maybe I don't want to do that. I don't want to be creative on those 3, 2, 1.
Okay, so I'm gonna go ahead and throw this up here and then we can discuss it. So when you discussed, I hoped you used the medians because they're pretty easy. So you can see that the Apple tablet has a slightly higher median overall rating at about 84 than the Samsung at about 83. So the median ratings themselves really aren't that much different. Now, remember why you would do this, right? Have you ever watched one of those YouTube videos where they're like rating the new iPhone or something like this? You're trying to tell people that one is better. Why do you have two phones? Anyway, you're trying to get people to buy one product over the other. So telling them that they have about the same median rating isn't really doing much for you. So you could follow that up with the fact that if you look at the graph of the Apple ratings, 75%, or this 2 halves of the box and the right whisker, are all above the median of the Samsung. So you might want to say something like, more importantly, about 75% of the Apple tablets had an overall rating that were greater than or equal to the median of the Samsung tablet. Now you've got a comparison that makes people want to buy an Apple tablet. Okay. Then you need to say something about unusual. So you might mention those 2 outliers.
Outliers, that might be like the iPad 2 that's still circulating around that you bought
Um, you probably want to say something about the shape. Both of these are skewed to the left because of that whisker. And then you want to say something about the variation. Make sure that your variation you're talking about is IQR. I went so far as to say that it really looks like the IQR of the Samsung is 4 times larger than that of the Apple. Now, why is that a bad thing?
Because if I'm going to choose one or the other, I don't want to have to worry. Maybe I'm not the most tech savvy. I want to know that if I pick an Apple tablet, I'm going to pretty much have a good chance of getting a good product. If I just randomly pick a Samsung tablet, I may pick a good one or I may pick a bad one because I have a greater variability. So if I just don't know and I just go to the store and randomly grab one, I should grab an Apple if I'm based on this graph.
Okay, one more. And it's FRAPPY. Okay, I'm done. So here's your AP question, your free response AP question. Yay!
Can we dance every time we do one?
Do what?
Yes, we now have to dance every time we do a free response.
We're gonna, yeah, for sure. We'll dance every single time you see a FRAPPY. I'll try to do something better than just like this move though, because that's all y'all got this time.
I'm old, so that's all that you're gonna get. Bad dance. No, you're not gonna get the sprinkler. You're just gonna get this.
Okay, all right. So we've got. Actually, I'm not going to read it to you because this is an AP question, so you need to read it. There's one part that you're not seeing though, so start with these first 3. Give yourself about 10 minutes to do these first 3. You could even set a timer if you want. Pause the video.
We're back.
Okay, so now you kind of know what you're looking at. We're back to that 2010 census. This time we're looking at males and females versus owning and renting property or houses. So the first one, hopefully everybody got it, says what % of males own their own home? What % of males own their own home?
So we're looking at males, and these are the males who own, and them's is my totals.
So if you did 132 out of 348, then you did what % of people in the sample own their own? Well, actually, I don't know what % of, oh, you did, what in the world would that be? Males
who own their own home out of everybody.
Yes.
Of all.
Yes.
But that's not what the question asked you to do. You were limiting yourself to just males.
Yeah. B says, make a graph to compare the distribution of housing. And guys, there are a lot of things that you could do here. You can do a side-by-side bar graph, which is what you're going to see here. But you also could have done a stacked bar graph. So either one of those is perfectly fine, okay? What you need to make sure of is that you did all the labeling and you did a key. So you need to have gender, male, female. You need to have frequencies. You need to make sure your frequencies are counting by the same interval. And you need to make sure you've got that key, that own rent key, and you've somehow either shaded or done dots, or somehow you have told the reader which one is which.
And what you might do is, like, you could do one bar like this and do one bar like this. Well, I could draw a line. Because if you don't happen to have 2 different pens handy, you can make one box like that and the other box like that.
Part C says, using your graph from part B, describe the relationship between gender and housing status. So, gender and housing status.
They seem, those 2 graphs, the male and the female, male and female graphs, now it came on to, you got passed it on to me. Those seem to have similar kinds of percentages.
Right. So what we might say is that because they look alike, there doesn't really seem to be an association between gender and housing. Like, I couldn't say, I'm female, do you think I own a house or don't own a house? Because I don't know, because they're the same. So, you know, say something along the lines of there's no association because of the graphs being so similar. Okay, part D. We're going to pause. You got to take about 5 minutes. Okay, so now we're looking at married versus not married and the own and rent. Okay, so just a little different. And it says for the members of the sample, is the relationship between marital status and housing status weaker than the relationship between gender and housing status? And so you got to find a way to convey this to the reader. So I hope you made a graph so that you could compare them. Yeah, you could have done this based on percentages, but it would have just been more difficult. And when I look at this graph, do I see an association? What do you think, Mr. Robbie? Do you see an association?
That it seems like married people, or at least there's 80% of the married people have a home versus only 60. So those bars are further apart for married versus not for married. So I would say if someone is married, they are more likely to own a home.
Right. And so there's a lot of words that you can use here. Make sure you actually answer the question, which is that stronger or weaker relationship. So you need to at some point address that question. The association is stronger than that of the gender because the difference in the percentage of owning a home is greater than blah, 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 blah. So you can kind of look to see what's written here. I'm going to take you over to the scoring and scroll through the scoring guide so that you have a chance to look at your EPI and decide how you did.
And folks, I know y'all probably could have done a lot of this before you even had this class, or we started talking about these videos, but those little nuanced things about talking about the context, doing the linking the two, those are the things that are going to help you get through the AP exam and that make your arguments stronger. It's not all just about the AP exam or you're great. I know you think it is, but ultimately in real life, you're going to have to convince somebody of something. And if you make a better argument based on data, you're more likely to get them to believe what you're trying to say.
Absolutely. At some point in your life, you're probably going to have to read some statistics and make some argument based on that. So we just want you to be prepared for that. Okay?
All right.
Thanks for joining us for the video. And we have one more before this is all said and done.
Oh,
bye, guys.
Was there an assignment after this? Was there an assignment page and a dog?
Oh, hi. So actually, there's a dog.
There's a dog. There's my doggy.
Thanks for reminding me because I've needed all the reminding on this video. There's no more Khan Academy assignments for 1.5 through 1.9, but there is a quiz 1.5 through 1.9. So make sure you go back through your notes from 1.5 through 1.9 and be ready to take the quiz. Okay? Bye, guys. Have a wonderful morning, evening, or night, depending on what time of the day you're watching us.
Bye.